Let's look at this very easy problem. Invert binary tree. So what we are supposed to do over here is we are given a tree like this. It's a 4, a root node. 2 and 7 are the left and the right child respectively. 1 and 3, the left and the right child of the root 2, and so on. What we need to do is we need to switch the left tree with the right tree, or the left child with the right child for all the root nodes. So for 4, we switch these position. It was 2 7, now it's 7 2. It was 1 3, and now it is 3 1. You can see something interesting. This moved here because these were the children of 2, and that would remain the same. These are the children of 2. This relationship would remain the same. So what we are basically doing is we are switching every subtree. We are reversing every subtree. This 2 would reverse its tree, its subtree, and so on. Let's look at the code for this, and it would be very simple. So we are in the code editor. We are given this function invert tree. It takes a root of the tree, and it's supposed to we are supposed to return the root of the inverted tree. The one thing I want you to understand is that it is a recursive problem. And why is that? So let's say if I have something like this. I have something like this. If I can find the logic to reverse this, then this is just a subproblem. This is just a subproblem. And anything after this would be just a subproblem. So in this uh, problem, I would like to use recursion. We would create a logic to reverse these two nodes, and then we would call this function recursively to apply the same on this root node. Let's look at the code. What we want to do is we want to switch. So basically root dot left equals to invert tree, recursively calling it root dot right, right? We are basically saying that, okay, root dot left is equals to, you know, this root dot right, but inverted. So get me the inverted of the right. I want to connect it with my left. That is what it says. Similarly, root dot right equals to self dot invert tree root dot left. That, you know what, root dot right, let me just draw it over here for better clarity. Something like this, something like this. That, you know what, root dot right, roots right, connect this with the inverted form of root dot left. Connect it like this. And root dot left, connect it with the inverted form of root dot right. Root dot right. That's how we connect it. Let's go forward with the code. Over here, I can return the root. Now, as you may have seen, we have a problem with this implementation. We are actually modifying root dot left. So when we pass root dot left over here, it's a modified version of root dot left. We don't want that. You know, when we swap two numbers, if a is equals to 2 and b is equals to 3 and we want to, swap these numbers, we use a temporary variable to preserve the value that is lost due to assignment. So over here, this root dot left is actually polluted. So what we want here is we want a temp which stores this value, this node, this location. We want to preserve it so that we can use it later. So since now this is polluted, over here instead of root dot left, I use temp. Also, what happens when I reach the leaf node? In that situation, leaf node is it says okay, leaf dot right, which is none, and none does not have any more children, so there is no need to reverse it. So how about we handle this edge case? If root equals to none, there is nothing more. There is no reverse after that. So just return none. Let's try to run this code. It's passing. Let's submit it. So we have a solution to this problem.